right, so let's talk about the scientific method and how we do science. The most important part of science is a hypothesis. A hypothesis is a statement, and it is a tentative answer to a question. It is an answer to what is that, how did that happen, what is going on here. It is a proposed explanation for something that we see. So let's say that my cat, I'm going to keep talking about my cat right now because we're going through a thing with her. She's old and she started throwing up all the time. Sorry, science is sometimes gross. So my cat has been throwing up. So we observe that the cat has thrown up several times. And our original hypothesis is she ate something that makes her sick. So the first thing that we did was we did an experiment. I'll come back to that in just a moment. But our hypothesis is not what's wrong with the cat. That's a question. Our hypothesis is the cat ate something that made her sick. Okay, so that's our hypothesis. The hypothesis is one step in the scientific process. So here's a graphic of the scientific method with a baby. The baby makes an observation. Ooh, there is a green thing on the ground. I wonder what that is. The baby forms a hypothesis. This will be good to eat. So the question is, what is this? Is it good to eat? The hypothesis is this will be good to eat. Then the baby performs the experiment. That's the next step. So the baby eats the thing. And then the baby analyzes the data. You can see the little baby's face turned green. And the analysis shows this is not good to eat. Part 5, report your findings. Now, when it comes to me and my cat, this is not particularly important to report the findings to anyone except my daughters, who are helping me figure out what's wrong with the cat. And here, the baby reports its findings only to the people nearby by screaming. And then the other step in the scientific method is to invite others to reproduce the results. So in this case, the baby turns to another baby and says, here, try this, which, just cracks me up. All right, so what is a hypothesis versus what is a theory? We have very specific ways of using the word theory in science. And we should always, honestly, just say scientific theory, but we don't, so here we are. The hypothesis is a proposed explanation for an observation or sometimes a couple of observations. It must be testable. A theory explains lots and lots and lots of observations. Theories are supported by lots of evidence, not just by observations, not just by something we saw, but by experiments, by measuring lots of observations. So a hypothesis is my cat is sick because she ate something bad. A theory would be certain organisms are toxic to other organisms. Okay, so if my cat ate a lizard, then she's going to throw up because she's an idiot who can't remember that lizards make her sick. The theory covers not just cats, but all organisms, all things that eat other organisms. A law is a statement that describes something observed through repeated experiments. So a theory explains laws. Okay? There is a law that carnivores eat other animals. Okay? That's just a law. Gravity is a law. Gravity is a law that says that smaller things are pulled toward larger things. Anything you drop falls toward the earth because the earth is so much larger than anything on it. The moon revolves around the earth because the moon is smaller than the earth. The earth and the moon revolve around the sun because the sun is much, 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 much larger than the earth and the moon. They are drawn to the sun or pulled toward the sun. That's just a law. Now, the theory of gravity is actually super complex and involves gravity actually being waves, and I don't actually understand it, but they finally observed gravity waves just in the last few years This has now become an established and accepted theory of gravity. Okay, so a hypothesis is the thing that we think of as just a theory. Okay, when we say, my theory is blah, 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 what we really mean is my hypothesis is, okay? My theory is my cat ate a lizard and she got sick. That is actually my hypothesis. The scientific theory is a much bigger thing that is overarching and describes many, many observations and has been tested by testing many, many hypotheses. Hope that makes sense. Now, here's another example. Animals with white fur are hard to see in snowy habitats. That's just an observable fact. Anytime there's a white animal on a white background, it's going to be hard to see. Our hypothesis could be white fur is an adaptation that helps polar bears survive in the Arctic. It makes them harder to see by their prey so they can sneak up on their prey more easily. The theory is animals better adapted to the local environment are better able to survive and reproduce. You can see again, this theory covers many, many observations, hypotheses, and laws. Okay, so a law doesn't grow up to be a theory. A theory is the overarching structure that explains lots and lots of laws and has been tested and is supported by many hypotheses that have been tested. Scientific theories aren't perfect because they are human endeavors. They are human efforts to understand the natural world. They aren't perfect. Like I said, we just really got the final support for the theory of gravity. Theories make predictions. Theories can be tested. Theories are also adjusted to fit new data. So some people like to say that Darwin's theory of evolution was disproven when people figured out DNA. Well, it wasn't. Darwin knew that there was something that was passed on from parents to offspring, but he didn't know what it was. DNA supported the theory of evolution by natural selection that Darwin came up with by showing us what it was that was passed from parents to offspring. We adjusted the theory of evolution by natural selection to say not that there is something that is passed from parents to offspring, but that DNA is passed from parents to offspring. DNA is the thing that determines the traits of the offspring or any individual. Okay, so scientific theories are always being adjusted as we learn new things, as we do more science. But the important thing to remember is that a scientific theory is not just a theory. Okay, it's not just a theory the way we throw around that word theory in everyday life. It is a very specific scientific thing. All right, so I'm going to stop there. In this next video, we're going to talk about what it means to be alive and how we distinguish between something that is alive and something that is not alive.